thank you for coming. I know the sun is shining outside and sangria is flowing. This is the last talk. I hope it's going to be fun. So I'm Fabio and this is Peter. We both work for the same infrastructure team in Salesforce. And our team is a global team. We're spread all over the world because we need to support the Salesforce developers 24/5. And we're spread a little bit in Japan, in India, Ireland, and US.
And I've been on the team for 10 years, so it's becoming kind of a rare thing at Salesforce for someone to be on the same team for 10 years. So what we're talking about today, I've been on the team for 10 years. Fabio, you're
6
years?
Yeah,
five or six. So we have a lot of continuity, a lot of background in what we're going to be talking about today. So we'll present what we know, and then hopefully there's lots of questions.
Okay. So the idea is I'm going to bother you a little bit at the beginning, giving you a little bit of context of why a bunch of Java developers ended up managing a large Monorepo. And hopefully at the end, Peter is going to wake you up with something important, some demos. So our team in Salesforce has this mission. The idea is to provide tools, services that is going to, in some way, is going to free the development teams from toil. And this is hopefully going to make them focus on the real value of their services. And hopefully it's going to make me rich at some stage, hopefully. So, but before we dive in, let's understand a little bit the context. So, in Salesforce, the foundation component is a large monolith that we call core, and it's been there for a while. It's rich in features, and it's pretty big, and it's handy because when you work in core as a developer, you get everything for free, and sometimes people ended up writing code inside of core even if you didn't want to be there in the end, because it comes with a lot of weight. So what happened at some stage? The microservices were on a rise, and people have started to think, okay, maybe I can work outside. I can create my services outside of core. And when that happened, then people started to realize that they started to have problems that before they didn't have. So how can I send my log to Splunk? How can I send metrics to our observability platform? And at some stage, everybody was trying to fix the same problems, so wasting a lot of time, a lot of money, and it was not effective. So someone came up with an idea. What about if we create a team that is going to provide some solutions, some whatever, to provide a global solution to all these teams? So something that is going to look like more or less what they had in core before. And that's when my team was formed at the beginning with a very awful name that was Salesforce Container, and nobody liked that. Thanks God we had a very smart dude in our team that managed to find something good inside of that. So we ended up calling ourselves Scone. And this is a scone, if you're familiar with that, I hope so. It's a little bit ugly, but it's good. So at that stage, the team was formed by JVM developers, mostly Spring Boot expert. So guess what we did? We started to write our own starters, and because we liked our name so much, we ended up calling this set of starters Scone. And all these starters that you see there, they are this is the current status of our starters. We were way before in the past. We ended up decommissioning some of them while Spring Boot was getting smarter. And they are effective, so effective that they got popular in very no time. And we started to release new version of Scone quite often. And at that stage, we started to face our own success because we had so many consumers, and those consumers were coming to us saying, okay, there is the vulnerability. When you're going to address that? I'm on Scone 5. How can I jump to Scone 9? It's going to be, it was pretty tough for us. And we heard about someone doing something different. Other companies, they were trying to use this idea, the idea of using a monorepo. that stands for monolithic repository. I don't know if you're familiar with that, right? The idea is instead of having several different repositories for several different services, you have one large repo where a lot of services, they coexist, where they are related but independent, where independent means that they can be built, tested, and deployed independently without affecting each other. Hopefully they can contribute to each other though. So the idea is, instead of a monorepo, you can reuse libraries, and that's exactly what Scone was. Our Scone was actually a library consumed by a lot of people, so upgrading Scone or improving Scone, we could actually change our consumers as well. It simplified refactoring because we didn't need to release something on Nexus to see the effects on our consumer. In the same context, we could change Scone and see exactly what was happening to our consumers. Inside of a monorepo, you can spot issues on an earlier stage of development. And the most important thing is going to give us some tooling, some alignment, because we wanted to keep our consumer up to date regarding feature or vulnerabilities. Okay, we like the idea, but then what? How do you do that? Maven and Gradle don't fit very well in that case. So we ended up going to the checking what the industry was offering at the stage. And there were a lot of competitors. We bet on Bazel, that is made out of Blaze. If you ever heard about it, that is developed in Google. This is the open source version. At that stage, it was not that fast and not that correct. Now they became a little bit less humble, and they are fast and correct, to be honest. But that stage, it was the very beginning. It sounded pretty good because what it was promising, it was incremental builds, where Bazel always knows when you change something, how many small targets are really impacted by that. So in that build, when you change something, only the little impacts will be built again. So it's pretty effective. It's pretty fast as well, and it scaled pretty well. It's actually designed for large monorepos. Something that is amazing is the fact that it's hermetic. Hermetic means that the machine where the tests are running are not meant to affect the outcome of your test. So you can repeat it as many times as you want, and it's always going to be the same. It's a polyglot environment. So in the same monorepo, you could have Java, Go, Python. Bazel doesn't care. You can build and compile everything. It's not important. And even better, it comes out of the box with remote caching and remote execution. So that means that it gets even faster. And over there, maybe, makes sense, totally makes sense. But you can see it's so specific that you can build a Java library and you can say what is needed for compiling and what is needed for running. And when you see the double slash for each line, that means that it's something inside of the shared repository. When you see the at, it's something coming from outside, something that is loaded in some way. Okay, it sounds amazing, but it wasn't perfect. No, there was very little pure ID support. Now it's way better. There are a few options over there. The community was very small, and something that we didn't like at all, there was no Spring Boot support at this stage. And over there, this is Peter committing for the first time in our monorepo. So guess what? This guy close to me did that. Okay, I'm going to make my own Spring Boot plugin. So for Bazel, rules are kind of the plugins for Maven or for Gradle. And Peter started this project, and now it's open to the open source community. And is rich of features. It's way better than the Maven and Gradle options, in my opinion, because there are a lot of features that maybe you didn't even consider that you need, and Peter is going to show you some. And it's now considered the standard. If you work with Bazel and you want to create a Spring Boot app, you're going to use that, so you're going to know Peter's name at some stage. So this is This is how you build a Spring Boot application. Pretty clear, in my opinion. And this is just creating the fat jar that you get from Maven for free. This is going to do the same exact stuff, but it's a little bit more advanced. OK, so all the tools are in place. I mean, we are still developers. We're not magicians. So we have to enforce some policy. So the idea is we are going to update all of our users inside of our monorepos, but they have to use only one version of each dependency in our monorepo. So there will be only one version of Spring, only one version of any library that you want, so that we can scan our repository. And whenever we need it, we are going to upgrade it. Upgrading the library is going to trigger the build of all the consumers, and we're going to release them all. There is a little star. Of course, we are not idiot. We know it doesn't fit for everybody. So there are exceptions. So in case you really cannot do that, we have an option. Second thing, we do the same exact thing for Docker images. So inside of our monorepos, everybody starts from the same base image because we are the owner of the base image. So whenever, I don't know, Salesforce decides that we need to move to another version, another kind of base image, we do that for everybody. And they automatically get it for free because this code probably won't even change. And in case you're wondering, you still have the same flexibility that you would have with a Docker file because we provide the layers. So I don't know if you're familiar with that, but I mean, in the end, a Docker image is kind of a cake, and you can put as many layers if you want on top of that. And we provide them. In this case, for example, we have the AWS CLI, Git, and JQ, and zip. OK, even this one, it was done. Continuous integration, because of course, everybody, when you talk about monorepos, the first thing they say, OK, I don't want in my PR to have someone else's code built, because nobody wants that. Bazel is not going to make that happen. So our users usually care about only the first two builds over there. So they send their PR. They see their PR getting green at some stage. They merge. And then there is another build that is going to go there, analyze commit after commit the status of the repository. It's going to say, OK, something has changed. I'm going to release it. And it's going to push out things. It can be Docker images, it can be jars, it can be RPMs, anything. All the other stuff is just for us. So we are the guys in the truck. So we need to constantly scan and check that our repository is in a good state, because we need to be sure of that. Our full build nowadays is more or less is 10 hours. So we need to be sure that everything is fine. Also, we have a lot of validation builds because we need to be sure that everything is fine, it's not misconfigured. We collect the code coverage for everybody. And more important, we look for vulnerabilities, so problems. So we analyze that, and in case we do something. OK, we liked it so much that for a few years we had only a Java one, and then we ended up having a Golang one a couple of years ago because the Golang community in Salesforce was so happy about what we had for the Java one. And recently we started a Python one as well. So this is the status of the art. We manage, we watch out, I don't know, 200 jars, a lot of images, a lot of users, because we have support channels as well. So every day we need to talk with them to see if something is not working or they need support. And this is the amount of PRs that we send every day, every year to patch our users. So long story short, this is how we became the guardians of the monorepos. Yeah, that's it. And now, Peter, please.
Sure, thank you. So you have the context now. I'm going to cover some of the things we had to conquer, some of the challenges we had. We had to conquer user fears. So sometimes recruiting developers to come into a monorepo, they get really scared because they're worried that they're going to lose control, and they're worried that we're going to block them from doing productive work. And so There's just a set of things that we conquered in the next few slides, and then we'll do some demos. So one of the first things we hit, that's a flock of birds picture over there migrating. So when we set up the Monorepo, we needed to migrate in the mostly Maven projects into the Monorepo, and we thought this was going to be a big hard problem, and we looked around for migration tools that would take us from Maven into Bazel, and we were really kind of worried about it. And it turns out this is a pretty simple problem. It's you just scan the POM, and then you just generate a Bazel file. So yeah, that turned out to be an easy thing to do. And then the next thing, though, is we had to deal with plugins. So there's a lot of code generation happening inside of Maven builds. And so we had to solve that problem. And then the next thing is we started generating projects brand new. Sorry. Brand new in the repo. And so that turned out to be an easy problem too. Sorry. The next thing is dependencies. So we have 1,400 dependencies under management now, and so we kind of look at them as like our flock of sheep. So we have to keep them moving forward. The good thing is automation handles 90% of the upgrades. So we just cranking in the background is most of our upgrades. But then 10% is handled by us, so we have to go and do manual fixes. And so this turned out to be like a problem that we thought we were going to get behind on, and it was going to be difficult for us to keep up with. But over time, it actually hasn't been much of a problem. One thing we do is upgrade transitives. So if all of our services depend on dependency A, and A depends on B, and B depends on C, we'll actually upgrade C, which kind of surprises people, because A hasn't upgraded that dependency yet, but we'll do that, and we found that that's actually pretty safe. Pretty much patches almost are never a problem. Minors sometimes, and then majors can be. Then we have, as Fabio said, we have these cases where services can't take our single version. And so what we do is we have what we call unmanaged dependencies. So we let them kind of pin back on an older version. This was pretty easy for us to do in Bazel. Bazel supports this, has flexibility. But the problem we found was that once teams moved into the shared repo or Monorepo, no one wants to work on it. So we have all this tech debt with these old dependencies, and so we have to, like, if you do a Monorepo, you got to kind of figure out what your contract is with your users. Who's going to do those upgrades from the unmanaged to the managed versions? The other thing we do is vendoring. So, like, sometimes a library will be, you'll have a vulnerability in a open source library, and sometimes the open source team just doesn't have the bandwidth to fix it quickly enough, and we work under a lot of compliance regulations, and so sometimes we have to go in and fix the vulnerability before the open source project does, and so that's another service we provide inside of our Monorepo. We'll copy in the code, make the change, and then we get instantaneous adoption across all of our services. So that's a big benefit of a Monorepo, is like from just within minutes of us doing the vendoring and patching, we can actually get those Docker images sent out. Another thing we were worried about when we first started the Monorepo project was doing like major upgrades. And so if anyone's done the Spring Boot 2 to Spring Boot 3 upgrade, one of the things we were worried about is like once you're in a big Monorepo, like so we have 150, 200 services, we were worried that we would be blocked on doing major upgrades because we have to do all of them at the same time. But we found ways to do it. Bazel's pretty flexible. So to do the Boot 3 upgrade, what we did is we separated out of those 1,400 dependencies, probably about 1,200 aren't impacted by the Jakarta Boot 2 to Boot 3 changes, the Jetty changes. And so we separated those out as common dependencies. And then we have 2 ecosystems of the other ones, like the Spring ones. And so then the services will just depend on the right set of dependencies. And so this is allowing us to do gradual migration. So we've got about 70% of our services now up on Boot 3 inside the Monorepo. Outside the Monorepo, it's about 30%. So it just shows that, you know, if you leave it up to the developers, they don't want to do this kind of stuff. So this is a big selling point for us. And then we do some other things like we do just like hygiene. So duplicate classes is a big one. So that's the case where there's 2 jars that provide the same class but with different code. And so we enable that. And then like for this Boot 3 upgrade, we have a JavaX detection. So if somebody tries to add an old jar to a Boot 3 app, we detect that. And then also we look for like things like JUnit. All right. So I'm going to do some demos.
Cool.
Okay. So this is not our repo. We're not allowed to show our repo. So this is just like a Spring Boot app inside a Bazel repo with our Spring Boot rule. And some of the things you'll notice is so at the top level there's something called module.bazel, which loads our Spring Boot rule. And then it has, in this case, it has a list of all of our Maven dependencies, our open source dependencies. In our bigger repo, we don't have it in a single file like this. Bazel's flexible enough for us to split that across, you know, like 50 different files. And so, but in this simple example, we just have it all as a list here. And so it's one place, again, single version policy, just one place to define your dependencies. And then for our demo app, we have this is just a basic Spring Boot app, and it has our list of dependencies for that app, also some internal dependencies, some internal libraries, and then it gets rolled up into a Java library, and then down here this is where we define the Spring Boot application that gets generated. So this is the uberjar. That's what the Spring Boot rule does, is builds that uberjar. So let's just launch it real quick. And there's a breakpoint. And this is not a JetBrains talk, so I'm not going to do much more than this. I'm just going to launch it to show that your debug experience with the Spring Boot Bazel system is just as it would be with Maven. So I'm going to close that down, and then from here on out, I'm just going to use the terminal because it's I want you to see the Bazel interactions. So the next demo I want to show is so the command to build a repository in Bazel is just that, Bazel build, and with all the targets. But usually, especially in a large monorepo, you're only going to be building the app that you care about. And so in this case, I'm just building down to this demo app that's in the examples directory. If you notice that the critical path here is 0, which means everything was cached. So Bazel, again, is very good about not redoing anything. So, but then let's just prove that that works. So we'll do I just changed the main file, and now the critical path was 1 second because it had to recompile that file, but also rebuild the app. And then again, back down to 0 because I didn't change the file again. So also, the way some of the Bazel magic works is it keeps persistent processes around. So that's why it's continually it's got a cache of everything it's built in memory, and so it's really quick. And of course, if it gets too big, then it'll write to the file system. And then test is as you would expect. So then again, test results are cached as well. So in this case, I ran test again, and everything was cached, and so it was instantaneous. So as Fabio said, our full build is 10 hours. Full build and test is 10 hours, but in most cases, users don't experience that because unless you do a full blast radius change, most things are cached. There's some interesting things, like you can do some queries. So Bazel has a really good query interface, so you can query your dependencies, and you can graph it as well. And we'll just do a few quick things. Let's remove. So we have in Maven you have the ability to exclude dependencies. We have the same thing. So in this case, we're going to remove. So Tomcat's coming in transitively by the Spring Boot starter web. So we're going to remove that. So now if we were to do this again, and then look for Tomcat, it won't be there. Well, it's there, but that's a trick of Bazel. What we want to look for is in the jar file, the actual produced jar file. If you look for Tomcat, it won't be there. Sorry. Now it won't be there. So that was the proof that it was there to begin with. And now if you look in the jar, it's not there anymore. And then the other thing, like I was saying, we do dupe class checking. So in this case, we have this set to false because we intentionally have a duplicate class in here. So in our in the build, we have something intentionally that's duplicated. Of course, it's a demo, so it's not showing. Give me 1 second. Okay, it's not going to do it. So normally when you have a duplicate class, it'll fail with an error. For some reason, it's not happening right now. Sorry, what? Oh, right, yeah, yep. Thank you. So we do allow you to override this behavior, and so this sometimes in cases where you can't remove the duplicate class, we have that ignore list. Thank you. Very helpful.
I didn't know this.
And then the last thing, so sometimes this happens, especially internally at Salesforce, some people forget to, when they add a test dependency like JUnit or Makito to a library, they forget to set test scope on the dependency, and so we have the capability to check for that. And so in this case, we're going to add JUnit to the library, and then it's going to fail when we try and build. And so, a lot of this is just we're trying to move a lot of things that would ordinarily be caught at runtime or caught in production at runtime into the build. And so in this case, it shows that JUnit was detected and said, you can't do it. I think that's it. So in summary, the Monorepo it's a technical thing, but it's also a governance thing. So I don't know. Want to say anything else?
That's cool as well.
Any questions?
Anybody? Yeah.
Yep.
Yeah. So you showed that, for example, for Spring Boot support, you needed to provide your own Bazel implementation. What does it do out of the box, like running JUnit tests, for example? Is that something that Bazel says knows what to do?
Yeah. So a lot of your tests, like unit tests, are just JUnit tests. So Bazel does that. Spring Boot test, it's also the same.
Yeah.
Yeah.
No, pretty much it's the same experience.
Any bill of material dependency calls or are you just managing that yourself, like flat list?
Yeah, flat list. We do have transitive information, so we do get that through Maven, but it's mostly flat list.
So you don't rely on Spring Boot managed dependencies, for example.
No.
Yeah, okay.
Yeah. All right, if you're lucky enough, someone has already made a rule for that. But Bazel comes with Starlark. There is the language that you can use for writing your own stuff. So it's a programming language, and you can implement whatever you want.
What's your experience? So how often did you have to implement something yourself, and how often was there something already?
Peter had to do that for Spring Boot.
Yeah, early on, there was a lot of bootstrapping that we had to do, but it's a pretty big community now, so it's it's not as common.
No, it's not that common, exactly.
Is the community really into monorepos? Is that the main use case for Bazel? Or?
Yeah, that's what is designed for that. Please.
How do you do your deployments? So when it takes 10 hours to build, all the applications?
We don't deploy because we only maintain the services, and then the service owners, they deploy their own Docker images, because our job finishes when the Docker image is ready, for example in the registry. Then our users decide what to do with that.
Yep.
Sorry?
To be clear, the 10-hour build is only for big blast radius changes.
Yeah.
But if you just change your service, it's like 20 minutes.
So the long builds are for us, because when we change scone, all the downstream dependencies, they're affected. So probably this is the biggest PR you can create in our shared repository. Other people, they just release their own stuff, so they don't see that. Sorry? We there is first of all, we announce what we do. It's not coming out of a surprise. Then there are mechanisms in the company where there are some people that trust the process enough, and there is a continuous integration that would be triggered in some cases, and also, I mean, yeah, we rely on test. So we ask people in our Monorepo to have at least a coverage of 75% of coverage. So whenever we change something, if the coverage is good, probably we didn't break anything. It still can happen, of course, it happened, but we are quite confident that this is not gonna affect anyone if the coverage is good.
And also there's other teams that have scanners that let them know that they need to patch a vulnerability, for example.
Oh,
so
yeah.
that happens after us.
Please.
If you're developing an app, I guess you don't check out the whole monorepo. How are people working with such, well, a relatively large monorepo?
Okay, yeah.
Yeah, you can do sparse checkouts with Git, but it's still not that bad to do the full repo, and then you just build your segment.
Yeah, also in IDEA, in IntelliJ, the Bazel plugin is smart enough because this is a common problem. You don't want to see a huge tree on the left, so the plugin can be configured to see only what you want to see. So it would look like a simple project, but actually it's a huge stuff under the hood. So the experience is the same, more or less. Please.
Now that it's so easy for people to create shared libraries because they're just
Yeah.
built, have you also seen that people really start doing that more, that they start to share code or put it in libraries?
Yeah, someone did that. I mean, in Salesforce we have several people that try to mimic what we did with Cone, and yeah, we have a couple of clones actually. Yeah.
And there's, of the 200 libraries, half are other teams.
Yeah.
Yeah.
Any other question? Okay. Thank you so much. Thanks for
thank you.
coming.